Rhapsody Best Practices. Best practice configuration is a broad topic which ultimately resolves to some fundamental principles which should be continuously applied during configuration and maintenance of a Rhapsody site. These principles will be encountered frequently during the Rhapsody professional course, some directly and some indirectly. Broadly, they can be summarized as follows. Build route layouts, which clearly identify purpose and functionality and which are presented logically. Ensure that the configuration is built to process messages efficiently. Establish a clear naming convention for filters and connectors, which identifies their function. Establish a clear naming convention for communication points, which identifies their purpose. Document components using a standard template approach. Document any changes. Test each component fully before submitting the configuration, and ensure test messages and procedures are incorporated into the configuration. Additional best practice guidelines apply to the design of a configuration. These will be discussed in a later module. Naming conventions. Naming conventions are focused on allowing the implementation of configurations which are essentially self-documenting. They should enable components to be labeled in a manner which is clear and indicative of purpose. This will simplify maintenance by both internal and external resources by reducing the time needed to understand the purpose of the configuration. Character set. The range of valid characters available for use in component names should be established. Key points for consideration include use of spaces and names. Spaces are preferred as word separators since they format better in Rhapsody and are easier to read. Valid characters, while the IDA limits the character set to the alphanumeric set 09 AZ, AZ, AAZ of few punctuation characters, it is normally preferable to limit punctuation to ation. Route naming. Routes are utilized in the IDA and Management Console to provide information on the path taken by a message as it passes through the Rhapsody engine. Naming convention should allow easy identification of the route's purpose. For example, PASADT feed or PAS2RIS. You can also number routes to indicate the order in which they will process messages. For example, the source route would have the prefix 1 and the delivery route prefix 2. Communication points. It is preferable to have a communication point instance in a single route, even if the message is to be used by multiple routes. This is because it is easy to lose track of routes, likely to be affected by stopping or starting a communication point. This may be achieved by placing the communication point on a separate route and establishing a message feed to the requisite downstream routes. This is also more efficient in terms of storage requirements. Each connection from a communication point will save a copy of the message to the data store, so receiving once and distributing is more efficient. In situations where one of the downstream routes is not running, messages will be placed into the route queue for the disabled route waiting for processing to resume. Careful queue management is advised in these scenarios, as large queues may have undesirable impacts on the engine, particularly at engine restart. FIFO. Route design needs to take FIFO into account. If there is a branch in the route which would enable a message to be delayed, the design should be modified so that further messages are not delayed by the slow processing of previous messages. Message definitions. The route framework permits one or more message definitions to be registered with the route. If required by the processing logic, the input message is parsed prior to processing by the first filter on the route, and an implicit property is added to the message containing the name of the definition used in parsing. Caution should be exhibited where it might be deemed necessary to add multiple definitions to the route, as the definition used for parsing in this case will be indeterminate because the engine will simply pick a definition. In this scenario, it is preferable to separate the parsing step from the processing step and ensure that the correct definition is used at the parsing step. Path management. The processing logic should generally follow a path from left to right. Paths should not cross. Use no operation filters if necessary. Each path should generally proceed towards the output connections, that is, input connections should be made from a component to the left of the filter. Output connections should be made to components to the right of the filter. This will be limited to some extent by connections from the no-match and error connection points. No-match connections should generally be made above and to the right of the filter. Error connections should generally be made below and to the right of the filter. Where it is necessary to deviate from these guidelines, ensure that filters are correctly labeled to indicate the processing path and the no-operation filters are used to keep the flow logic clear.